Hello. Given a real-valued function, how do we compute its domain algebraically? This is what I'll talk about in this video using a specific example. Let's read through the question one time. Question: consider the real-valued function f of x equals square root of the quantity 2x minus 10. Part A, find the domain of f algebraically. Part B, sketch the graph of f and indicate its domain on the graph. Before we can get started on the question, let's make sure we do know what the meaning of this word is, domain of f. So let's read through the precise definition of the domain. The domain of a real-valued function f is the set of all real number inputs x for which the corresponding output f of x is also a real number. So for this question, if we apply the definition of the domain of a function, we see that a real number x should be included in the domain of f if and only if the square root of the quantity 2x minus 10 is also a real number. This will happen whenever 2x minus 10 is greater than or equal to 0, since we know the square root of a negative number is not a real number. So summarizing this discussion, this is what we get. By definition, the domain of the function that we have been given is the set of all real numbers x for which 2x minus 10 is greater than or equal to 0. Let's now solve this inequality. So we write 2x minus 10 is greater than or equal to 0. Adding 10 to both sides of the inequality, we get 2x greater than or equal to 10. Dividing both sides of the inequality by the positive number 2, we get x greater than or equal to 5. We now write the domain of the function in an acceptable notation. We may either use set notation, which starts with curly bracket, and we write x, a vertical line, which we read as such that, so the set of all x such that x is greater than or equal to 5. If you wanted to view the domain, or in other words, this set on a real number line, this is how it would look. The set of red dots that you see out here on the real number line, we can also write them in a different notation like this, using bracket. Start with the left-hand point, which is 5. We use a square bracket because 5 is included then, comma. And as you can see, our set of red dots go on forever, so infinite. And then we always end with parentheses when we have infinity. So we've figured out the domain of the function, and we've also learned how to express the domain in both set notation and interval notation. There are an infinite number of points in the domain of the function. Anytime x is greater than or equal to 5, we can put in that number into the function as an input and get an output, which is a real number. In contrast, if you pick any of the real numbers to the left of 5, and if you put them into the function as an input, then you would get square root of a negative number, which is not a real number. So the points to the left of 5 are not included in the domain of the function. Instead, the domain of the function, as we figured out, includes 5 and all of the numbers to the right of 5, which we can write either in set notation or in interval notation. Here's the summary from the last slide. In set notation, we said the domain was the set of all x such that x is greater than or equal to 5. And in interval notation, we can also write the domain in this manner. And here's a picture of the real number line. So part B says, sketch the graph of f and indicate its domain on the graph. So graph of f, you may do it using your graphing calculator and indicating its domain. As you know, domain is the set of all real number inputs, and those you will find on the x-axis. So here's the domain that we see it, 5 included, and all of the numbers to the right. As you can see, For each of these points, the function is defined. As you can see, the graph lies above this particular piece of the x-axis. For the given function, we have figured out the domain of the function algebraically, and we've also noticed if we sketch the graph of the function, then the graph of the function lies exactly over the domain that we figured out. So everything matches up. Here's the complete write-up.